So, very good afternoon to all members gathered here. Today, we are in the next lecture series on SolidWorks course Assembly Design. So, here we are going to see some of the main aspects of assembly design using SolidWorks with a demo tutorial at the end of the session. So, what does it mean, assembly design? An overview. We will look into further consideration. What is meant by assembly design in SolidWorks? Assembly design basically involves creation of parts and managing the multiple parts within a single document in order to represent a complete view of a product or a system. And this also allows for simulating how the parts interact with each other and evaluating the fit and tolerance of the part and facilitating the smoother design changes. And it can be done either using bottom-up approach or top-down approach. These are the two methods, assembly methods followed in assembly design, or a combination of both. What are the various key aspects of assembly design in SolidWorks? The bottom-up design, it starts with individual part design and assembles them sequentially as per the precedence constraint. Top-down design starts with overall assembly layout and then creates or modifies the parts within that context. And what do you mean by layout sketches? In top-down design, the layout sketches can be used to define the overall structure and relationship between each parts before any parts are created. So we have to construct an assembly layout in 2D by explicitly defining each part structure and the corresponding relationship with each other. Then mates. Mates can be defined how parts can be positioned and how they interact with each other by specifying the constraints like distance, angle, and concentricity, etc. And complex subassemblies can be broken down into smaller and manageable subassemblies. The design validation in assembly model. Assembly model allow for simulating the behavior of the final assembled product, including motion and interference check to identify the potential design flaws present in the assembly model or not. Whether all the parts are joined according to the precedence constraint and find out is there any loose assembly joint in the model. So for that we have to go for simulation. So with the help of the design validation. The drawing creation from the final assembled model, 3D model, drawings can be created directly from the assembly structure, showing the various components and their interrelationship. Now we will go through the step-by-step assembly process model of machine components, say design of flange coupling joints using SolidWorks.
this video we are going to design flange coupling that you can see on the screen right now. So now let us begin it. Go to the new part. Okay. Now we do the sketch and select here the front plane. Now here we draw a circle of diameter 220 mm. Now we go to the features and select the extrude post feature and go to the depth as 22 mm. Okay. Again go to the sketch and select its face, make it normal. Now here draw a circle of diameter 120 mm.
Looking to take the next step in your career, then you have to get this AWS course on Udemy. It gets you.
Now we go to the features and select here the extrude post feature and to the depth as 120 mm. Okay. Now again go to the sketch and select this face, make it normal, and here we'll draw a circle of diameter 100 mm. And now go to the features and select here the extrude cut feature and select here throughout. Okay. Now go to the sketch and select this face, make it normal. Now here we draw a circle over here. Go to the smart dimension and the circle diameter is 20 mm and the distance of center of the circle from the origin, that is 85 mm. Now we'll exit the smart dimension, select the center point of the circle and select here the origin and give it here the vertical. Okay. Now select here the circle, go to the circular sketch pattern and give here 6 such circles. Okay. And now we'll go to the features and select here the extrude cut feature and select here throughout. Okay. Now we'll go to the fillet and give the fillet radius as 3 mm and select here this edge. Okay. Now we'll make here the plane wide. Then select here the part, go to the appearance, select here the metal, steel, and give it here the polish steel. And now we'll save it. Go to the save as. Now select here the desktop, and on the desktop we'll create a new folder and we'll name it as a flange coupling. And give the name of the part as flange. Okay. Go to the new part. Okay. Now we'll go to the sketch and select here the top plane. Now here we'll do a hexagon, 3 polygon features like this. And select the side and make it here vertical. Okay. Now we'll give the smart dimension and give the distance between the opposite sides as 28 mm. Now we go to the features and select here the extrude post feature and give the depth as 12 mm. Okay. Now we go to the sketch and select this face, make it normal. Now here we'll draw a circle like this. Then select the circle, press Ctrl and select this edge and make it here tangent. Okay. Now go to the features and select here the extrude cut feature. Now here select clip side to cut and give the draft angle as 60 degree. Okay. Now we go to sketch and select here this lower face, make it normal. Now here we draw a circle of diameter 20 mm. Now we go to the features and select the extrude boss feature and give the depth as 75 mm. Okay. Now we go to the chamfer and give the chamfer distance as 1 mm. And then select here this edge. Okay. Now we go to the sketch and select here the front plane. Make it normal. Now here we have to draw one horizontal line like this. Now we go to the smart dimension and give the distance between the line and its edge as 40 mm. Now we'll exit the sketch. Then we'll go to the features and in the curve select the split line and then select here the cylindrical face. Okay. Now select the part, go to the appearance and in the appearance go to the metal and select here the brass and give it the brush. Now select the space, go to the appearance and here we have to go for the miscellaneous and in the miscellaneous select here the pattern and give it here the screw thread. So here you can see that cosmetic threads are applied and now we'll save it. So we'll go to the save as and give the name of the part as gold. Okay.
எழுத படிக்க தெரியுமான்னு கேக்குற காலம்லாம் போய் ப்ராம்ப்ட் பண்ண தெரியுமான்னு கேக்குற காலம் வந்தாச்சு. ஆமாங்க, நான் சாட் ஜிபிடி
Go to the new part. Okay. Now we'll go to the sketch and select here the top plane. Now here we draw a hexagon which is polygon feature. Now go to the smart dimension and give the distance between two opposite sides as 28 mm. Now we'll exit the smart dimension. Now select this line and make it here vertical. Okay. Now we go to the features and select here the extrude boss feature and give the depth as 12 mm. Okay. Now we'll edit the boss extrude and give it here the mid plane. Okay. Now we'll go to the sketch and select this face, make it normal. Now here we draw a circle like this. Then select circle, press Ctrl and select this edge and make it here tangent. Okay. Now we go to the features and select the extrude cut feature. Now select here clip side to cut and give the draft angle as 60 degree. Okay. Now select this cut extrude and go to the mirror and select here the top plane. Okay. Now we go to the sketch and select this face, make it here normal. Now here we draw a circle of diameter 20 mm. And now we go to the features and select the extrude cut feature and select here throughout. Okay. Now we go to the chamfer and give the chamfer distance as 1 mm. And then select here this edge and this edge. Okay. Now select the part, go to the appearance and give it here the brass and give the brush. Now select the surface, go to the appearance and give it here miscellaneous, go to the pattern and select here the screw thread. Now save it, go to the save as and name the part as a knot. Okay. So till now we have created all the parts and now we are going to make assembly of all the parts and for that we'll go to the view and select here the assembly. Okay. Now first we import the plane like this. Now we put the plane white. Now again we put the insert component and select here the plane. Now we put the mat. Then select here this hole and select this hole. And here we have to fill the reverse. So click on the flip mat. Okay. Then select here this circle and select here this face. Okay. Then select this face and this face. Okay. Now we close the mat. Now we put the new component and select here the bolt. Now we put the mat. Then select here this cylindrical portion and select here this hole and click on the flip mat. Okay. Now select this face and here select this face. Okay. Now we'll close the mat. Now go to insert component and select here the knot. Now we'll go to the mat and select here this inner portion and select here this portion. Okay. Now select here this face and select here this face. Okay. Now we close the mat. Now select here the bolt and go to the circular pattern. Now here we have to select this face and give the instances as 6. Okay. Now we select the knot, go to the circular pattern and here again select this face and give the instances as 6. Okay. So here you can see that we can design the flange coupling using SolidWorks. Hope you enjoyed the tutorial. For more videos on SolidWorks tutorial, please subscribe to my channel. Get Tech tutorials.
So we have gone through the demo video on the step-by-step assembly of flange coupling model using SolidWorks. So with this information, I conclude the end of the lecture. So using these different tools and methods, the SolidWorks assembly design facilitates efficient design of complex products, enabling better collaboration and ensuring that the final product meets the desired expectations as per the specification of the customer. So once again, I thank all the members. So we have completed the basic fundamentals of the SolidWorks course. We will meet in the other lecture with another new topic. So thank you once again.